Before planting comes preparation. Before harvest comes groundwork. For generations, the hardest job in farming wasn't planting or picking. It was breaking ground, turning virgin prairie into productive farmland, busting hardpan that choked crop roots, working heavy clay that defeated lesser equipment. This brutal work required massive implements pulled by powerful tractors, creating the foundation for American agriculture. But today we're counting down the 10 most powerful vintage tillage tools ever built. Implements that conquered the toughest soil conditions and transformed impossible ground into fertile fields. From traditional moldboard plows that turned perfect furrows, to aggressive chisel plows that shattered hardpan, these machines represent raw power meeting agricultural necessity. Let's discover the implements that literally broke new ground. Starting our countdown at number 10 is the John Deere Model 55 Moldboard Plow, the traditional tillage tool that sets standards for furrow quality. Released in the 1950s, the Model 55 represented Deere's evolution of the moldboard plow concept pioneered generations earlier. While the basic principle remained unchanged, turning soil completely over to bury residue in exposed fresh earth, Deere engineering refined every detail for reliability and performance under continuous heavy loads. The 55 featured individually mounted bottoms with trip mechanisms protecting against hidden obstacles. When a plowshare struck rock or stump, the bottom lifted over the obstruction, then reset automatically, preventing catastrophic frame damage that destroyed competitors' rigid designs. This innovation allowed confident plowing in newly cleared land where hidden obstacles lurk beneath the surface. Deere engineers optimized the moldboard shape through extensive field testing. The curved steel surface turned furrows cleanly while minimizing draft. The pulling resistance that determined how many bottoms a tractor could handle. A well-adjusted 55 required less power than competing plows, allowing farmers to pull additional bottoms or work faster through heavy soil. The 55 offered configurations from 3 to 7 bottoms, matching various tractor sizes. Proper adjustment was critical. Too shallow left hardpan untouched, while too deep wasted power and time. Experienced operators adjusted plow depth by soil type, working deeper in loose sand than tight clay. The Model 55 found its market among farmers committed to traditional moldboard plowing. For thousands of operations from the Midwest to the Great Plains, this green and yellow implement represented the foundation of soil preparation. Turn the earth, bury the residue, start fresh each season. International Harvester commands number 9 with the 370 Disk Harrow, the secondary tillage tool that finished what plows started. Introduced in the 1960s, the IH370 was a tandem disc harrow designed for the critical work between plowing and planting. While moldboard plows turned soil and buried residue, disc harrows broke clods. It leveled the surface and created the fine seedbed crops demanded. The 370 excelled at this essential but often overlooked work. The implement featured front and rear gangs of notched disc blades, each gang angled to throw soil toward the center. This opposing action broke clods while keeping soil in place rather than pushing it sideways. IH engineers positioned the gangs for optimal clod breaking without creating furrows that required additional smoothing. Blade diameter was critical to disc harrow performance. The 370 used 20-inch or 22-inch blades that penetrated deeply enough to reach plowpan, but weren't so aggressive that they created new compaction. The notched edges grabbed and shattered clods rather than riding over them like smooth-edged discs. Individual gang flexibility allowed the 370 to follow ground contours, maintaining consistent working depth across varying terrain. Rigid disc harrows scalped hilltops and rode over low spots, but the flexible 370 worked the entire field uniformly. Farmers appreciated not needing multiple passes to correct rigid implement problems. Weight determined how aggressively discs cut into soil. The 370's frame weight could be supplemented with bolt-on weight brackets, allowing customization for soil conditions. Lightweight for loose, dry soil, heavyweight for wet clay that resisted penetration. Many farmers considered the 370 the finest finishing implement IH ever built, essential equipment for creating ideal seedbeds. Allis-Chalmers enters our countdown at number 8 with their innovative Snap-Coupler Moldboard Plow system. the quick-change implement that revolutionized plow mounting. Before a seized snap coupler, changing implements meant crawling under tractors, aligning hitch pins through holes while holding heavy implements, then securing everything with pins that always dropped into mud. The process consumed precious time during busy seasons. Allis-Chalmers eliminated this frustration with the snap coupler system introduced in the 1950s. The snap coupler mounted permanently to a C-tractors, providing a standardized connection point for all compatible implements. The plow attached to this coupler with a quick latch mechanism that locked from the tractor seat. Hydraulic lift connected automatically through self-aligning couplers. One farmer could change implements in minutes without tools or assistance. A C's Moldboard plow capitalized on this convenience while delivering traditional plowing performance. The plow featured spring cushion bottoms that absorbed shock loads, protecting both implement and tractor from hidden obstacles. The spring mechanism allowed momentary overload without triggering the full trip mechanism, reducing unnecessary resets that slowed fieldwork. Plow bodies used AC's specially shaped moldboards that turned furrows with minimal draft. Soil rolled off the polished steel surface smoothly, reducing the power required compared to competitors. This efficiency let AC tractors pull more bottoms or maintain faster ground speeds through heavy soil conditions. The hydraulic lift system provided precise depth control from the operator's seat. Bore adjustments during operation allowed compensating for varying soil conditions without stopping. This adaptability maximized efficiency during long field days. The snap coupler concept eventually became industry standard, but Allis-Chalmers pioneered the system that made implement changes practical for solo operators. Case dominates number 7 with their massive 18-bottom moldboard plow, the largest traditional plow ever offered for farm use. During the 1970s, as farms grew larger and tractors more powerful, Case recognized opportunity in extreme capacity equipment. While competitors offered 6, 7, or 8-bottom plows, Case engineered an 18-bottom monster requiring the largest articulated 4-wheel drive tractors to operate effectively. The implement stretched nearly 50 feet wide when unfolded for work, covering enormous acreage with each pass. In ideal conditions with powerful tractors, operators could plow 40 to 50 acres per day, productivity that matched or exceeded smaller farms' total acreage. This capacity allowed large operations to complete plowing during optimal weather windows rather than racing against deteriorating conditions. Case designed the 18-bottom plow with sophisticated hydraulic folding systems that reduced transport width to legal road dimensions. The outer sections folded vertically, creating a towering but narrow profile for highway travel. Unfolding in the field took minutes, transforming the implement from transport to working configuration. Each plow bottom featured Case's proven trip mechanism and replaceable shares. With 18 bottoms experiencing continuous wear, or a replacement body were significant operational expenses. Case engineered the plow for quick field repairs, allowing operators to replace damaged shares without returning to the shop. The massive plow demanded meticulous maintenance. 18 plow bottoms working heavy soil generated tremendous forces transmitted through the frame. Daily inspections caught developing cracks or bearing wear before catastrophic failures occurred. Operators learned to service this implement religiously or face expensive breakdowns during critical plowing seasons. The Case 18 bottom plow represented the ultimate expression of traditional moldboard plowing before conservation tillage made plows obsolete. Krause commands number 6 with their heavy-duty offset Disk Harrow, the aggressive implement that conquered ground other discs couldn't touch. Unlike tandem disc harrows with opposing gangs that worked soil without moving it sideways, offset discs threw everything in one direction. This aggressive action made offset discs ideal for incorporating heavy residue, breaking virgin sod, or reclaiming overgrown fields. Krause built the toughest offset disc in the business. The company's offset harrows featured massive disc blades, 26, 28, or even 32 inches in diameter, that cut through roots, stalks, and tough sod like smaller discs never could. The huge blades maintained momentum through obstacles that stopped lighter implements, keeping ground speed consistent even in challenging conditions. Krause engineered exceptionally heavy frames that drove those massive blades deep into soil. while competitors built lighter implements requiring bolt-on weights. Krause frames provided inherent mass that ensured consistent penetration without additional ballast. This simplified design reduced maintenance while improving reliability. The gang angles on offset discs determine how aggressively they move soil. Krause Harrows offered adjustable gang angles, allowing operators to match aggressiveness to soil conditions and residue levels. Steep angles for heavy residue, shallow angles for final smoothing. Bearing systems in offset discs faced brutal service. Tremendous side loads from throwing soil combined with abrasive contamination from dust and debris. Krause used sealed, grease-packed bearings sized beyond industry standards. Properly maintained, these bearings survive seasons of hard use before requiring replacement. Many farmers purchase Krause Offset Disks specifically for the toughest ground, using them to reclaim neglected fields or incorporate exceptionally heavy residue, then switching to lighter implements for routine work. John Deere claims number 5 with the 1610 rigid chisel plow, the deep tillage implement that shattered hardpan without inverting soil. As farmers recognize problems with continuous moldboard plowing, erosion, organic matter loss, and hardpan formation, interest grew in alternative tillage methods. Chisel plows offer deep soil fracturing without complete inversion, leaving residue on the surface for erosion protection while breaking compaction layers that restricted root growth. The 1610 featured heavy-duty C-shanks mounted to a massive toolbar. Each shank carried a narrow chisel point that fractured soil 6, 8, or even 12 inches deep, depending on shank spacing and tractor power. The narrow points required far less draft than moldboard plows covering the same width, allowing operation at higher speeds or with smaller tractors. Deere engineers designed rigid shanks rather than spring-cushioned types. Rigid construction delivered maximum soil fracturing while simplifying maintenance. No springs to break or adjust. In rocky or root-infested ground, shear bolts protected the shanks and frame from damage, breaking deliberately to prevent catastrophic failures. Shank spacing determined how completely the chisel plow worked soil. When close spacing, 6 to 8 inches, fractured ground thoroughly but increased draft. Wide spacing, 10 to 12 inches, reduced draft but left unworked strips between passes. Farmers chose spacing based on soil conditions and compaction severity. The 1610 could be configured for various tasks by changing points. Straight chisel points for deep fracturing, twisted points for more soil mixing, or sweep points for shallow surface work. This versatility made the implement useful across multiple seasons and operations. The 1610 represented the transition from traditional tillage toward modern conservation methods, deep work without complete soil inversion. International Harvester returns at number 4 with the 490 Tandem Disk Harrow, the finishing implement that created perfect seed beds. Released in the 1970s, the IH490 represented the evolution of Disk Harrow technology. Building on lessons from the earlier 370, the 490 offered increased capacity and improved performance for the larger tractors and farming operations emerging during that era. The implement featured 4 gangs of 22-inch notched blades configured for superior clod pulverization. Front gangs angled to throw soil outward, while rear gangs angled inward, creating opposing forces that broke clods without creating furrows. This sophisticated gang arrangement produced level seed beds requiring minimal additional smoothing. But individual gang flexibility allowed the 490 to maintain consistent working depth across varying terrain. Each gang pivoted independently, ensuring all blades contacted soil uniformly rather than some scalping while others rode in air. This flexibility proved especially valuable in rolling or terraced fields where rigid implements performed inconsistently. Bearing maintenance determined Disk Harrow longevity. The 490 used sealed bearing assemblies that resisted contamination while requiring minimal service intervals. IH engineers designed the bearing mounts for quick replacement when service became necessary. Remove 4 bolts, pull the gang, replace the bearing assembly, reinstall. Field crews could complete bearing changes without returning to the shop. Hydraulic folding wings reduced transport width from 30+ feet to less than 15, allowing legal road travel without special permits. The folding mechanism was robust enough for daily use during planting season, when implements move frequently between fields. But many farmers considered the 490 the finest Disk Harrow ever built, the standard against which competitors measured their own designs. Versatile storms into number 3 with their heavy offset Disk Harrow, the Canadian-built implement that broke ground American equipment couldn't handle. Versatile manufacturing, known for building massive articulated tractors for Western Canada's vast wheat country, applied similar philosophy to tillage equipment. Their offset Disk Harrows were built heavier, stronger, and tougher than American competitors, each designed specifically for breaking virgin prairie and reclaiming neglected land. The implement featured 32-inch disc blades, substantially larger than industry standards, mounted to frames built from structural steel heavy enough for bridge construction. This massive construction allowed the versatile offset disc to power through roots, rocks, and sod that stopped lighter implements. Weight alone drove the huge blades deep into resistant soil. Gang angles adjusted through a range allowing operators to match aggressiveness to field conditions. At maximum angle for the toughest ground and heaviest residue, reduced angles for lighter soils and final smoothing. This adjustability made the implement suitable for both initial groundbreaking and subsequent finish work. Versatile designed the disc specifically for the prairie's demanding conditions: heavy gumbo clay when wet, concrete hard when dry, mixed with roots from generations of native grasses. American offset discs often failed under these conditions, but versatile Harrows were engineered for exactly this service. The offset disc's aggressive side-throwing action made it ideal for terracing work and waterway construction. Operators could move soil efficiently while simultaneously incorporating residue, accomplishing multiple objectives with single passes. Farmers discovered the versatile offset disc excelled at reclaiming land that had been idle during drought years or economic downturns, breaking dense weed growth and restoring fields to production quickly. Case IH commands number 2 with the 4,800 Weber-Schenck Chisel Plow, the innovative implement that added vibration to deep tillage. Introduced in the 1980s, the Case IH 4,800 incorporated revolutionary Weber-Schenck technology. Rather than rigid or spring-cushioned shanks, the Weber-Schenck mechanism allowed controlled oscillation during operation. This vibration shattered soil more effectively while reducing draft compared to static shanks. The physics were straightforward. Vibrating shanks encountering compacted layers created rapid stress cycles that fractured soil more completely than steady pressure. The oscillation also reduced draft by preventing compacted soil from building up ahead of the shank points. This dual benefit, better soil fracturing with less power, made the 4,800 exceptionally efficient. Each shank assembly featured a curve standard that flexed under load, storing energy, then releasing it to create the oscillating motion. It had no external power source or complex mechanisms. The shanks generated their own vibration through interaction with soil. This elegant design minimized maintenance while ensuring reliable operation. Case IH engineers offered multiple shank spacings and point options. Close spacing with narrow chisel points for deep fracturing in severely compacted soil. Wide spacing with sweep points for shallow surface work incorporating residue. One implement served multiple tillage objectives through simple configuration changes. The massive toolbar accepted up to 15 shanks working ground 30 feet wide in a single pass. With articulated four-wheel drive tractors providing power, operators could work 40 to 50 acres per day, shattering hardpan that restricted crop roots while maintaining surface residue for erosion protection. The 4,800 represented the pinnacle of chisel plow technology before no-till farming reduced reliance on mechanical tillage. Taking the number 1 position is the John Deere 2800 variable width moldboard plow, the ultimate expression of traditional plowing technology. Released in the early 1980s, the 2800 represented Deere's final evolution of the moldboard plow concept. While conservation tillage and no-till farming were gaining acceptance, some farmers remained committed to traditional plowing. Deere engineered the 2800 as the most advanced moldboard plow ever offered. The revolutionary feature was variable width adjustment. Conventional plows turned consistent furrow widths, typically 14 or 16 inches. The 2800 adjusted from 14 to 20 inches per bottom, allowing operators to match furrow width to soil conditions. Narrow furrows for heavy clay that required complete turning, wide furrows in loose soil for maximum coverage. This width adjustment was hydraulic, controlled from the tractor cab without stopping. Operators approaching heavy soil narrowed the furrows for proper turning, then widened again in lighter conditions. This optimization maintained consistent plowing quality across varying field sections, rather than compromising with fixed-width bottoms. Each bottom featured Deere's most advanced trip mechanism that sensed obstructions and lifted automatically. Unlike earlier designs requiring manual reset, the 2800 bottoms reset automatically after clearing obstacles. This eliminated countless stops during fieldwork, particularly important when plowing newly cleared or rocky ground. The plow offered configurations from 5 to 8 bottoms, requiring the largest two-wheel drive or smaller four-wheel drive tractors. Properly ballasted and operated, the 2800 could plow 30 to 40 acres per day depending on soil conditions and furrow width settings. Frame construction utilized high-strength steel engineered through computer analysis, technology unavailable when earlier plows were designed. This modern metallurgy produced frames simultaneously lighter and stronger than older designs, reducing draft while improving durability. The 2800 represented the pinnacle of a tillage technology spanning thousands of years. From wooden plows pulled by oxen to this sophisticated hydraulic implement, the evolution was extraordinary. This wasn't just the best moldboard plow, it was the perfect culmination of a traditional tillage before farming moved beyond it. From the reliable John Deere Model 55 that turned perfect furrows, to the massive Case 18 bottom plow that covered unimaginable acreage, to the sophisticated Deere 2800 that perfected variable width technology, these 10 tillage implements represent raw power meeting agricultural necessity. They broke virgin prairie, shattered hardpan, and created the foundation for productive farming. Today, no-till and conservation tillage have made many of these implements obsolete, but survivors remain treasured by collectors who remember when breaking ground meant serious iron and serious power. What's your favorite vintage tillage implement? Share your memories in the comments below and subscribe for more agricultural history, because these groundbreaking machines deserve to be remembered.